This conference will now be recorded.
Okay, so our presentation today is going to be on the VAP 2000 moisture control coatings and systems, including our self-leveling underlayments and the entire systems designed to withstand high pH, high relative humidity, and high levels of moisture vapor emission rate in concrete floors. So obviously concrete is made with water, the presence of water in the concrete, and obviously from potentially exterior sources such as groundwater or topical water can contribute to a wide range of problems with floor covering systems and flooring systems in general. Normally, most commonly what we're seeing is adhesive breakdowns of adhesives due to that high moisture and high pH, debonding of flooring systems or coating systems, as well as osmotic blistering. In other circumstances, we can deal with some of these other effects, such as alkali attack, pop-outs, maybe from an alkali silica reactivity or some kind of reactivity of the aggregate, as well as staining, expansion, efflorescence, etc., including curling and cracking, especially around joints and saw cuts in the floor. But primarily what we're dealing with in terms of concrete floor moisture is adhesive breakdown, osmotic blistering, and floor coating or debonding. Debonding of flooring or coating systems. So what we're looking to avoid, opportunities or fixes retroactively or to avoid right from the get-go. Obviously, this picture here is of a resinous floor with osmotic blistering, which is caused, by high levels of moisture in the concrete. Here, more widespread blistering and debonding of sports flooring system due to high moisture. Here we have a picture of emulsification of glue because of normally that's caused by the high pH or the very high moisture condition, but primarily the high pH, as well as floors like these, which have tile and carpet with mold, and mold seems to be affecting these systems just because of that high exposure to obviously all of that moisture, high relative humidity, and moisture vapor emission. So what we're trying to do here is either stop from the get-go or provide a fix so that flooring systems can be installed without dealing with these distresses and these issues that can come up and be caused by the high levels of moisture in the concrete substrate. An overall guiding principle in the building design and construction is to prevent moisture intrusion in through the floor and have these effects on the flooring systems, is to think of the floor as part of the building envelope. So normally the roof and walls are thought of and constructed to exclude moisture, including wind-driven rain. But realistically, the floor is part of the building envelope and should be treated the same way, so that moisture, especially in the form of moisture vapor, can't contribute to distress in the building. Moisture within the concrete slab that can contribute to problems need to be either evaluated by accurate testing and needs to be dealt with efficiently by a topically applied moisture barrier if there is no vapor barrier present below the slab, or if there is a higher moisture condition present. Concrete floor slabs ideally should be finished with a minimum amount of pressure and consolidation for several reasons. Finishing equipment and procedures should be selected to meet the proper requirements for flatness and level without burnishing or really densifying the floor for most interior floor slabs that are going to receive floor coverings or floor coatings. These dense, really heavily troweled surfaces, first of all, they slow the rate of drying significantly, and they inhibit the bonding of any kind of most underlayments or topically applied coatings or any other components of the floor covering system. These ride-on trowel machines can weigh over 3,000 pounds, put a lot of pressure onto the floor, extremely consolidating the top surface of that concrete, as we can see in this picture. This photograph is of a concrete core cut from a dense power troweled floor. The dark surface is almost stained, as it appears to be like a dry shake or a stain treatment. This region of approximately top 1/8 inch of the concrete is due to what we call compression dewatering. That high pressure troweling densifies the cement paste at the top surface. Water is driven out of this zone while this zone is consolidated and densified. This treatment does produce very hard, flat, smooth surfaces. It might be appropriate for some warehouse looks and other applications, but is very unnecessary for interior floors that will receive adhered floor coverings or adhered coatings because it is so hard to work with and it doesn't accept most flooring materials and bond well at all. So once we know that a floor slab has high moisture conditions, there are many options to treat the floor. This slide indicates a couple of the options which range from low cost to higher cost. Floor slabs may have sporadic kind of isolated moisture problems that can be treated by repair locally as maintenance issues. An owner may accept the contractor setting aside some money for maintenance rather than interrupting the entire business and treating the entire floor. When possible, it's desirable to dry the floor, practically speaking, obviously from the top of the floor. Dry and warm circulating air can help, but air warmer than 80 or 90 degrees can have a negative impact on some of the other building finishes if there is casework, cabinetry, for example, in these areas. That very high humidity and very hot air can have an effect on any of the other finishes in the space. That's something to be cautious of if an attempt is made to dry the floor out. Usually by the time we know that floor slab is too wet for flooring installation, the flooring finishes have already been purchased, may even have arrived on site. It may be worth having a discussion with the owner whether alternate finishes, such as bare concrete, stained concrete, or alternative floor coverings may be acceptable. In most cases, though, this is simply not an option. If we're working in a school or a hospital, polished concrete and bare concrete is obviously not going to be an option. It needs some kind of resilient flooring to be installed. Floors with unacceptably high moisture conditions for the type of the specified floor coverings can be treated on the surface with a topical moisture barrier, either preformed membranes or more commonly liquid applied membranes. Finally, obviously, if a flooring has been installed that's not suitable for this installation, where there are high levels of moisture, where the floor has failed, it's necessary to remove and replace the entire floor, which is obviously the most costly method with the most associated downtime. So dealing with moisture mitigation from low cost to high cost, the lowest cost is to ignore it and hope that it doesn't cause an issue. The highest cost being obviously having to replace the entire floor because of a failure due to high moisture. That can all be avoided from the get-go by starting with a topical moisture vapor barrier. ASTM F3010 standardizes these moisture mitigation systems, these liquid applied membranes. It's the gold standard for liquid applied moisture control systems. It requires that the product, when applied, obviously according to the manufacturer's installation instructions and floor preparation procedures, allow no more than 0.1 perms of water vapor permeance. The product must have a minimum of 200 psi tensile bond strength to the concrete, must be two-component membrane forming material. So water-based products, silicates, and some of the penetrating and reactive products are not allowed under this practice. They're not standardized under ASTM F3010. Each product, obviously, like we discussed, must be installed according to the manufacturer's installation procedure, specifically floor preparation procedure, which is most normally shot blasting to at least an ICRI CSP3, and the application rate must be closely followed to produce the most effective and adequate dry film mill thickness. Typically, most of these products are 100% solid epoxies and are applied to give dry film thicknesses between 12 and 15 mils. So the approach of the liquid applied membranes is oftenly called shot blast and seal. That's it's mostly known as. Major advantages of this approach compared to a preformed rollout membrane is that this liquid applied system becomes permanently part of the floor. Almost any type of adhered floor coverings can be installed directly over the top of the moisture mitigation coating and can be renewed or replaced without any damage to the moisture vapor barrier or that liquid applied membrane. Membrane is usually applied to the concrete, and then sometimes a primer is used on top with self-leveling cementitious underlayments, depending on the installation. Obviously, quality control during the installation is very critical to performance. Concrete must be correctly profiled, clean, and liquid applied membrane must be applied at the correct application rate. If underlayment is installed, obviously care must be taken to follow the installation procedures of those products as well, mixing and applying carefully to avoid any kind of issue with the underlayment product. After the entire system is installed, it'll result in a hard, flat, smooth surface, ideal for any kind of floor covering installation. contaminants with concrete, it can also cause potential problems before floor coverings or before these moisture vapor barriers are installed. Reactive or expansive aggregate particles or contaminants may be in the concrete unreacted because of potential drier conditions near the surface of the concrete. After these coatings are installed to the surface to block the moisture vapor from being emitted out of the concrete, the moisture in the upper region of the concrete will increase, especially if there's no vapor retardant below the slab. The higher moisture condition, along with higher pH in the concrete, can cause reactions of aggregate that create spalling or cracks or bumps in the surface. The concrete can be tested before installation by petrographic or physical examination and by other methods to minimize the opportunity for such reactions. During install, we discussed that the guidelines we need to go through for quality control and field quality control during installation. The reason also it's important to perform so many field quality control installations during the actual application of the material, including checking the wet thickness of the material and the coverage of the material. The question is asked whether post-installation testing can be performed to certify or to demonstrate the performance of the liquid applied moisture mitigation membrane. At this time, no such tests are available because high moisture conditions may exist deep in the concrete, not close to the applied membrane in the top surface of the concrete. So it may take several months after that coating's been installed for the water moisture in the concrete to reach equilibrium and work its way up near the surface. The only test of moisture suppressant system performance requires destructive testing by taking cores out of the concrete and measuring the actual E96 water vapor transmission rate, or the PERM rating that we discussed earlier. Obviously, this is a destructive test that requires several months. So field quality control during installation is crucial to ensure that the correct film thickness is built on the surface and that there are no voids or potential issues which may come back to rear their ugly heads. Again, the environmental conditions in the area, we want to avoid any topical water being spilled onto the coating during its current period, including we want to stay above the dew point to ensure there's no condensation on the coating as it cures. And if we're using some kind of primer and a self-leveling underlayment, we want to ensure that those are all compatible with each other. This is a cross-section view of a 15 mil 100% solids epoxy coating, very similar to the VAP 2000 moisture mitigation system, which was applied to a shot blasted concrete surface. You can see the roughness of the surface where the aggregates are exposed. That provides that tooth for bonding of the epoxy to the concrete. The continuous film has sufficient mill thickness to serve as a barrier to moisture movement. If installation is done inadequately or improperly, and there are areas of the film that are too thin or discontinuous, it may allow moisture to transmit into the adhesive in flooring, leading to failure. The appearance here is desirable. Obviously, you can only see this by cutting out a cross section, but the way that you can determine that you have an adequate, consistent film is, again, by performing field quality control with mill gauges or monitoring the coverage of the coating and making sure that we're getting the correct coverage based on each unit that's mixed and installed. Here we have the permeance values for the products that we'll discuss that are in this VAP 2000 product line. This is installed at 100 square feet per gallon at 16 mils. Obviously, all of the perm ratings are below the standard of ASTM E96 and F3010 of 0.1 perms. They're all certified at a minimum of 11 mils. So this coating is normally installed between 100 to 150 square feet per gallon, between 11 to 16 mils, but 11 mils at minimum. The VAP 2000 system is a system that we've been kind of discussing that's formulated to prevent these kinds of flooring failures on concrete slabs with high levels of moisture, relative humidity, and alkalinity. These systems conform to ASTM F3010, so they are two-component liquid applied membranes, 100% solids epoxies. They're one-coat systems with one coat of insulation, no sand broadcast or a second coat or anything like that. No limit on moisture vapor emission rate. It can be installed on floors up to 100% relative humidity. They remain adhered with a sustained pH of 14, which is standardized by ASTM D1308. Spread rate on CSP3 is at least 150 square feet per gallon for 11 mils of wet film thickness, and they're available in 3-gallon and 5-gallon units. Recently, we've updated the packaging of these products. Material is now packaged in one plastic bucket with 3 flexible bags. It contains 2 bags of the A component, the resin, and 1 bag of B, or the hardener, already packaged at the correct mixing ratio. You cut the top or the corner of the bag, pour the components into the bucket, and mix. So you'd pour both A components into the bucket, and then add the B component, mix for your standard 2 minutes, and then the material will be ready to install. This facilitates shipping and reduces waste. Other forms of packaging and maybe metal pails and other packaging systems do take up a lot more space in terms of waste. With these systems, the bags, once they're used, take up very, very little space, so they're much easier to dispose of, and they take much less cost and space. These coatings, the VAP 2000 coatings, are also available to be pigmented. They can be pigmented in black or white. The first product that we'll discuss is the VAP 2000 FS. FS stands for Fast Set. This is a 0 VOC product that conforms to F3010. Again, I'm gonna sound like I'm repeating myself here, but all of the products conform to F3010. They're all one coat, 100% solids coating. This has about a 4-hour cure time with no limits on MVER or relative humidity. This can be installed on damp concrete, wet concrete, or SSD concrete, obviously with no puddles or standing water. Spread rate is the same as all the other products, at least 11 mils. The next product is the VAP 2000 Ultra Fast Set, UFS. Very similar product. This is a low VOC, low emitting product per lead version 2.1. This is a 2-hour cure product as well. The final product in the line is the VAP 2000 Zero VOC. This is another 0 VOC product with a 12-hour cure. This is very similar to the old standard VAP 2000 that was kind of the first product in this line. This is a 12-hour cure product with the 0 VOCs again. Some of the accessory products, we have the KOSTER TA fiber. TA is a thickening agent. This is a cellulose fiber-based thickening agent mixed to obviously adjust the consistency and used primarily in concrete repair. This is an alternative to fumed silica or other silica fillers that are very fine and potentially respirable. This is much less harmful. This is a non-toxic food-grade cellulose fiber. It's used to thicken coatings for filling holes or spalls. Primarily, this is used, we're going to discuss later how we seal cracks and saw cuts and other kinds of non-moving joints. The primary use for this is being mixed with the VAP epoxy from 1:1 up to 4:1 by volume to thicken the epoxy up for our concrete repair, again, in terms of spalls, joints, and other kind of areas that are need to be repaired before the installation can be performed. This is, again, all part of our preparation. The VAP 06 primer is what we'd use over non-porous surfaces. So this is a water-based one-component system which is used for priming non-absorbent substrates. Primarily, the VAP 2000 moisture mitigation system can also be used over terrazzo, metal, ceramic, core tile, etc., prior to the installation of cementitious underlayments. It's a one-component, 0 VOC, fast-drying product that dries in about 45 minutes to 1 hour, depending on the environmental conditions. Spread rate around 450 to 550. We like to say 500 square feet per gallon. It's relatively thin. It's a dip and roll product, but what you want to roll it out thin over, obviously the substrate, but you don't want to leave any puddles or ridges or very thick areas. It's very simple. Like I said, it's a dip and roll product. So if there are any ridges or thick areas, a pass over with the roller will just take up any thicker areas or clumps or puddles that are present. The other alternative is the KOSTER SL primer. This is a very low viscosity primer that reduces the absorbency of porous substrates such as concrete or screed for installation of the cementitious underlayments over these porous substrates. So it reduces any kind of pinholing event, effect when working with self-leveling floor products. If we're going over concrete with the self-leveler, or if we're doing an installation with different layers and different lifts and multiple lifts of underlayment, or working over porous substrates, normally we use the SL primer. Again, it's a one component, solvent-free, fast-drying material. Spreads between 650 to 800 square feet per gallon. That's all dependent on the substrate, whether the substrate is very porous concrete or other absorbent substrates, but the rate of absorbency can vary so much that we normally will run between 650 to 800 square feet per gallon. This can be used over concrete, over VCT, adhesive residue, and any other porous substrates. Level Strong Skim Coat is our new line of floor patch and skim coating material. This is made here in our facility in Virginia Beach. It's a silica-free floor patch with excellent bond strength, obviously very easy to mix and spread. It can be used for skim coating installations where it's put down very thin. It can be also used for ramping and void filling when it's mixed to a little thicker consistency. Flooring can be installed within 30 to 60 minutes. Depending on the environmental conditions, again, if it's skimmed out, flooring can be installed in as little as 15 minutes. It gives us that smooth, hard surface that we're looking for before we install our resilient flooring system over the moisture mitigation system. Again, this is made here in the US in our facility in Virginia Beach. The next product here is KOSTER Level Strong Self-Leveling Underlayment. This is going to be your everyday workhorse self-leveling underlayment with 40 minutes of working time. It's walkable depending on the conditions in about 3 to 4 hours. Any kind of resilient flooring or finished flooring can be installed in as little as 16 hours. It can be installed in layers between 1/8 to 1.5 inches per layer or per lift, neat with no aggregate. When used with aggregate, it can be used up to 3 inches per layer. The next slide is going to discuss how we do that with aggregate. It's shrinkage compensating, so it dries crack free, and it gives us, again, the dense, smooth surface and the controlled absorptive substrate for adhesives. What we say about that controlled absorptive substrate for adhesives, a lot of adhesives that are water-based or need to flash off or dry out, if they're installed directly over the non-porous moisture mitigation coating, they won't be allowed to dry fully, and they're not suitable for that installation. So this we call a blotter layer sometimes, and it allows the glue or adhesive to dry out before the flooring system is installed. This can also be used over adhesive residue, VCT, concrete, the moisture mitigation system, and everything like that. It's very low odor and it's very low dust product as well. Like I said, this is going to be the everyday self-leveling underlayment for use under resilient floors. So the deep fill systems are normally installed in multiple steps. There are layers installed with aggregate to recover height, and then a neat cap is poured to provide a smooth surface along the top surface of the concrete. To finish the layer of self-leveling underlayment with a smooth, neat surface. The primary methods in the past are obviously mixing stone or aggregate with the material and pouring the material out together with bags of underlayment and bags of stone or aggregate together, or potentially broadcasting aggregate into a wet layer of underlayment to try to build it up. The system that we've designed and come up with is to install a bed of angular aggregate, approximately a 1/2 inch to 3/4 inch diameter stone at the desired depth for the first layer. The KOSTER Level Strong is mixed and poured over the gravel bed. Over the course of several minutes, it fills voids in the gravel, it consolidates and de-airs. The surface of that underlayment pour can be finished with a smoother. Sometimes it helps to have a rake on hand just to take down any high spots in the stone that weren't visible until the underlayment was poured over the top of that stone. After the final layer, when the floor is ready for the final layer to be installed, it's installed like a standard underlayment installation with a gauge rake, sled rake, or similar tool, and can be finished with a smoother or a spiked roller or any kind of finishing tools that are that are standard normally used. Between any kind of layers, again, we use the KOSTER SL primer because of the porosity and the absorbency of the underlayment layer. The pictures here, we have, the top picture is obviously a prop and a mock-up that we performed. That's the picture of the stone laid out, not compacted, just laid out and screeded to level. And the picture on the bottom is a core that was taken out of the level strong, poured at 3.5 inches actually. So the entire height was 3.5 inches. The aggregate was poured down to set at 3 inches. The next couple of products are going to be more of niche products for niche applications, not your everyday products, but they are really, really great and do serve an amazing purpose and kind of very good to help you out when you're in a jam. The SL Turbo, for example, is the first product. It's very, very highly flowable, has a healing time of 20 or 25 minutes, can be installed as thin as 1/8 of an inch. This has a very, very short turnaround time. Finished flooring can be installed after 2 hours or less, depending on the environmental conditions. Coatings can be installed as well in 2 hours over the SL Turbo. After 3 hours, the compressor strength is already 1,500 PSI. At 28 days, it's a 6,000 PSI compressor strength product. So again, this is a system where if time is limited and you only have one night or one shift to come in and install the system, leveler, and floor coating or a Brazilian flooring system, this is a great product to help get in there and turn that around very, very quickly. The SL Flex is another kind of niche product. This is a flexible underlayment for use over multiple substrates. Primarily, it's used for repairing broken gypcrete floors or old wood subfloors. It can also be used over any kind of adhesive residue, most kinds of adhesive residue, and over VCT. This product is also walkable in 4 hours. It can be installed as thin as 1/8 of an inch up to 3/4 of an inch with normal spacing, depending on the construction. If we're going over elevated wooden floors at normal joist spacing, we generally don't go any thinner than 3/8 of an inch with this product, just so it has enough body to withstand the stresses of the deflection. But again, it is a 4,300 PSI compressive strength product that's very, very flexible and very high performance. Any kind of porous substrates that we go over, like these wooden subfloors, for example, can be primed with KOSTER SL primer. The final product of this kind of leveler line is the SL Protect. This isn't going to be like an everyday interior use underlayment. Think of this more as a heavy-duty overlay or a repair system. This is a very high-strength product for industrial use in shipping areas, warehouses, other areas that are subject to constant heavy traffic across the floors. It is an exterior rated product and it is polishable. It's walkable in 3 hours and the compressor strength is greater than 6,500 PSI. This can also be extended with gravel to up to 3 inches per lift and per installation layer. So circling back to the installation of these systems and products like these. So, we've discussed the kinds of products that are used, these liquid applied membranes that require an intense bond to the concrete to perform and withstand the very high levels of moisture vapor emission rate, as well as the pH and the relative humidity. The way that we achieve that bond with the concrete is by shot blasting. So shot blasting removes that top layer of cement paste of the concrete, opens up some of the pores, but primarily what it does is the direct impact of the shot fractures the aggregate and creates a condition where the aggregate pieces have almost infinite surface area for the coating to bond onto. So it greatly enhances the bond strength of any kind of coating to the substrate by increasing the surface area of the substrate. For example, we have a picture here of, obviously on the left side is a normal troweled concrete surface. On the right, we have floor that's been shot blasted to a CSP3. We can see what we call that salt and pepper, or that you can see where the aggregate is present. And obviously, in the field, you can feel the difference in texture and the profile that's achieved by that shot blasting. If we were to install one of our coatings over the floor on the left side, that that troweled concrete surface, we may not get very much bond at all because there's not much room for mechanical bond and there's not much penetration into the concrete based on a profile or roughness that doesn't exist on the left in a normal smooth troweled floor. When we talk about shot blasted concrete, CSP 3 at least, we have the texture required for a very, very strong mechanical bond. And we've had our VAP coatings tested. Normally, they are tested with failures in the concrete, tensile strength failures in terms of tensile pull-off. But primarily, we're looking at an average of about 650 psi when we perform pull-off testing by ASTM D7234. Cracks in joints should be stabilized against curl relaxation or movement with very, very high stiffness and high compressor strength polymers such as epoxy or polyurethane. The epoxies can also be extended with sand for economy and for additional stiffness. Only certain types of products work in this application. Most cement-based patching compounds first of all, they don't provide the necessary crack filling, the necessary bond, or the stiffness to prevent that curl relaxation and the movement of the concrete over time as that moisture returns to its equilibrium and any kind of curling or cracks may relax. So normally what we would do is we would use either the KB-Pox IN, which is a very, very low viscosity epoxy, originally designed as an injection resin, but it's low viscosity. It can penetrate into these cracks and fill and seal any cracks or joints. Primarily, this is used in kind of finer cracks. It can also be used with sand to, like I said, for economy and to kind of fill the system out. That's installed either poured out of a pail, or there is a gun that can be used to install this into very fine cracks. For wider cracks, spalls, and for most construction joints, we mix the VAP resin with the thickening agent, primarily the TA fiber, to create a mix that we can use to fill and seal any kind of saw cut or joint that needs to be filled. We never stabilize any moving joints or expansion joints. Any kind of expansion joint or moving joint has to be honored through the flooring system. After the material has been mixed, so we've added 2 bags of A, 1 bag of B, and we're mixing the material. The coating is poured directly onto the substrate. We don't like inverting the can on the floor to drain all material in case there is unmixed material along the sides of the pail, which may cause an off reaction. What we do is you mix. As we're mixing, we mix with a mechanical mixer, electrical mixer, normally about 400 psi, with a Jiffler mixer, Jiffy mixer, or spiral paint mixer. We'll want to go around the pail up and down to make sure that any kind of we've got good mixing along the bottom of the pail and the sides. Try not to mix too quickly or introduce too much air into the mixes. That may shorten the working time, especially in more humid or in hotter working conditions. But after we've mixed, we immediately pour all material onto the substrate. We work off of a wet edge. If there is a batch before, we always want to tie into a wet edge as well. Coating is spread with a squeegee, commonly installed with a 15 to 20 mil knot squeegee to give us that coverage between 100 and 150 square feet per gallon. Depending on the surface conditions, obviously that may change in terms of exact coverage, but that's where it's important to either mark out your batches, mark out how much area you think will be taken by one mix and one batch of material, or to track the layer thickness with wet film thickness gauge during installation. After the coating has been squeegeed out, it is back rolled to ensure uniform coverage, to work material into the surface and de-air the coating. Anytime we are back rolling, we use, first of all, epoxy rated nap rollers, normally like a 3/8 inch nap roller. And we want to delint those beforehand to ensure that no wicks or hairs or any kind of lint from the coating from the roller gets into the wet coating and cures in that coating. So we have a couple of reference projects here. Obviously, this is a very basic remodel in a Walmart in Fort Wayne, Indiana. Moisture vapor had been a problem with previous floors, so VAP 2000 FS was selected to control the moisture vapor while providing an even surface for the VCT to be installed directly to the top of the moisture vapor barrier. The shortened cure time of only 4 hours, first of all, saved time for the construction project, and because the product has 0 VOC, areas of the store could stay open during application and installation. So this is a project that was about 150,000 square feet in different phases, but the shortened reaction curing time and the 0 VOCs in the product allowed for minimum disruption to the store during the installation. Milby High School in Houston, Texas was a project we worked on several years ago. The high school was built in 1929 with a basement with a very old swimming pool that was no longer in use. The swimming pool is the picture on the bottom left here. The basement was to be repurposed and was used as exercise space for the JRRTC association at the school. The pool was filled in with concrete and covered with a new, and it was covered with a new concrete slab. The KOSTER VAP 2000 FS was used over the entire area with SL Premium to ease the conversion from obviously an abandoned basement with a swimming pool to an underground gun room and gun storage room for the JROTC class. So here are some pictures. Picture on the left is the floor with the moisture mitigation coating installed. The middle picture is after we installed the self-leveling underlayment. That product is a KOSTER SL Premium. And on the right is after the flooring has been installed and the room has been repurposed. So we're able to preserve a building that was almost 100 years old and repurpose an old, rundown, abandoned basement into a usable space, a conditioned space for the school and for the students. Very commonly, we work with sports floors, either indoors or outdoors, where tracks have very high moisture readings, which are too high to install the indoor running track or the sports floor system. So we use the VAP 2000 to seal the slab and allow installation of the track. Obviously, we have a before and after picture. On the right is the picture of the finished sports flooring system. Finally, we have this school with the hardwood sports floor and basketball court that was ruined by high moisture. You can see the picture on the left, some of the discrepancies in the reflection. You can see some of the wooden boards have bowed and expanded and caused the entire floor to fail, with a lot of these humps or raised areas in the flooring. The floor is repaired using VAP 2000 VOC. We use the VAP 06 primer as a bonding bridge for the self-leveling underlayments, and then we installed a new sports floor. Picture on the right is obviously the finished floor. So we were able to solve the problem and provide a suitable floor for the installation. So for further information about any of our products or their availability, pricing, it's probably easiest to consult our website, www.kosterusa.com. That's on the bottom of the screen there. Again, my name is Matt Sorensen. I'm the technical specialist for KOSTER. My phone number and email can be found on the website. They're also right here, techsupport@kosterusa.com. For sales support, contact Ray Hicks. He's our national sales manager. He can provide you pricing, or he can forward you on to your local sales representative. Any information about your local sales rep can also be found on our website. There is a contact page with